My project is weight kernel classification. So for the given data, firstly I have performed my EDA. Here I have imported all the libraries and imported the data using imported, as we don't have any like the name, it's a text file. We don't have any like the column names for everything. So I have taken the column names and just given the names as the column names in while importing the data. After that, I have checked the info like what's the data type of each and everything data. Here I can see like there are 210 entries in the data. So there may be some outliers present in it. So first let's perform the EDA. I have checked like count, mean, standard deviation, minimum value, 25%, 50%, 75%, and maximum values. So come on, let's start the EDA. So here I just check for the like the null values. So here everything is zero. After that I'm checking each and every graph, like is it right skewed or left skewed, like is it in a perfect shape or not. So like that I have just checked for that. And this particular thing, like for the outlier box plot, we'll generally do the box plot for the outliers detection. So here as you can see in the asymmetric coefficient, you can see like there are some outliers present in this one. So here you can clearly see this one. So so I need to remove some outliers. Definitely there are some outliers present in it that can affect my machine learning model. So after that, I have just make sure that for the numerical features, I have taken the correlation matrix, and I just compared each and every particular column with the other columns, like area with the perimeter, area with the compactness, area with the length of kernel group, area with asymmetric coefficient. So like that, I have compared each and everything with the other columns, such that I can know like how my data is spreading, how my data is present. So like those things, I will be able to know. After that, I have performed the interquartile range. So it's basically performed because to remove the outliers. So here I have first the quartile ranges of 25%, 75%. So this is the basic format that we generally use to remove the outliers. So so after removing the outliers, here you can see like there are 205 entries. Firstly, we have 210 entries. After that, we have 205 entries. So it removes the outliers in the data. After that, I just make sure that the independent features on the X and the dependent features is on the Y. And I have performed the standard scaling. The standard scaling is mainly done as because, so as you can see from the data, like area, perimeter, and area and perimeter are in like in the terms of tens, like 14, 15, like that. But the remaining things like compactness, length are in terms of like in the ones like 1, 2, 3, or 0.8, 0.9, so like that. So in order to make sure that they comes on the same scale, we are performing the scaling like those will be in terms of like zero, in between 0 and 1. So after that, I have just make sure that my data gets splitted in such a way that I can perform training with 80% of the data, and 20% of the data will be used for the testing. After that, I have just checked with the various types of algorithms, like which algorithm will be better for predicting the kernel growth. So I have just taken the logistic regression, which I got 95.112. It's a quite good accuracy that I can say. And after that, I have taken the decision tree classifier, which I got 100% accuracy. This maybe has arrived because of the overfitting problem. Let's just check. Let's just check for the other algorithms too. If I got like same 100% accuracy, then it might not be getting overfitted. But let's just check for the other algorithms. Here I have drawn the tree. After that, we have performed KNN using the default value. Like the default value for the KNN is like 5. So I have just used the KNN, which gave me like 95.12. And comparing with these three algorithms, like 95.12 is my highest accuracy. And let's just go to the next thing, where I have used the ni bus is equals to 3 instead of using the default value, as I have like only three outputs, whether it gives me like quite good thing, quite same accuracy or not. So I just make sure I just use 9 ni bus is equals to 3, where I got 92.68 accuracy. So somewhat better, somewhat nearer to it, but not good. I mean, after that I have used XGBoost, which it has given me like 97.56%. It's the highest accuracy in comparing with the other algorithms which I have shown you. So it's like 97.46%. After that, the support vector mission also gave me like 95.46%. After gradient boosting also give me like 97.56% accuracy. Gaussian naive base, like this is the lowest accuracy which I have got. It's basically like Gaussian naive base has given me the lowest accuracy, like 87.8. So maybe I think it's better if we just leave this Gaussian naive base for predicting this particular model. After that, I have performed with the random forest, which I got like 92.68%. After that, I have done the neural network using the TensorFlow and Keras, where I have taken first dense layer and another dense layer. After that, dropout and dense dropout, then the last final output layer, which has activation function of softmax. As I have only three outputs, the units will be three. And after that, I compiled that, and I have trained and everything. I just got like 97.56%. So comparatively comparing with the all models, I have decision tree classifier of 100%. But when we see the support vector mission, XGBoost, gradient boosting, neural networks, so all these have the accuracy of 97.56%. So maybe my decision tree classifier is just getting overfitted with the data. So it's better, let's use the XGBoost model. Yeah, most people use the neural network as their model, but let's use the XGBoost model. Like it's quite easy to implement for me. So here the same thing has been done. Like I have just imported the data. I just use the column names and everything. So instead of just doing and leaving the model, I just saved the model using pickle file. So and I got the same accuracy. In order to be our model to be the like user friendly, I have used the Flask application. Like here I have imported all the necessary libraries and standard scaling, logging and everything. This part basically deals with the logging thing. And here I just opened my wheat kernel file, and as because I have only saved it like classifier, like the XGBoost classifier and standard scaler here. So I'm just importing these two. If everything goes as per my, like if everything imported successfully, then then it will in the logging it show model and scalar import loaded successfully. Otherwise it shows the error loading in the model. So here this is for my home page, like at the rate app root. And here is the main thing, like here where I'll give the data, here where the classifier predict the data, and here itself we will get the result page. Here everything here the data is getting loaded, and here we will see the received data, and this data is converted into scale. So scale, after scaling the prediction is done just similar way as it has here. You can see here we just done the standard scaling. Here we have taken the data, we just perform scaling. After that we use the classifier to predict the data. So in the similar manner everything is getting done. Like here we have taken the data, scaled the data, we predicted the data. So I have taken the data in such a, like it will be user friendly. I have taken like if the output is equals to 1, I just assume that like it's a comma. If it's a, if the output is 2, I have assumed it's a rosa. If the result, otherwise the result will be like Canadian. So this, here we'll get like final prediction result is equals to like result. So this will be stored in the logger, and we'll get our result in the result.html page. So let's run our code here. Here you can see I have activated my Flask environment, and here I am running Python app1.py. So let's run it. So here you can see the URL is coming, and let's go here. So here as you can see, let's load some data. So let's take 13.99 and compactness as 13.83, and then and the compactness as 0.9183, and length of kernel will be 5.119. Let's take width of kernel as 3.383. After that we'll take the asymmetry coefficient as 5.234. After that the length of kernel groove is 4.781. Let's predict. whether it gives the what type. So here the result is comma. Yeah. So let's go back and check for another type of data. 19.11, 16.26 as the perimeter, and 0.9898081. For the length of kernel is 6.154, width of kernel is 3.93, and the asymmetric coefficient is 2.936, and the length of kernel groove is 6.079. Let's predict. It's a rosa. Let's go for another thing like 11.43, and the perimeter is 13.13, compactness is 0.8335. Let's take the length of kernel 1.5.176, and the width of kernel is 2.719. Asymmetry coefficient is 2.221, and last final length of kernel 5.132. Let's predict. Oh, it's Canadian. So let's take like our own examples. Like just let's assume that the area is like 15.61. Let's take the perimeter as like 15.22. The compactness, let's take like 0.9332. Let's take the length of kernel. Let's assume our own values like it's like 6 6.789. Width of the kernel is like 1.223. Asymmetry coefficient it's like 2.567. Let's take the length of kernel groove as 5.112322. Yeah, let's predict what it gives. I don't know. Oh, it basically gives the comma. Maybe by using those we'll get the comma. So in this way, I have implemented my project of the weight kernel classification using the XGBoost classifier and the Flask. So let's check if everything has done through the logs. Let's check and let's go down. Yeah, here. Uh, actually, yeah. Here, as you can see, my time here is 10:22, and here it's 10:19. Like we just given the data. Like here you can see it from 10:19. Model and scalar has been loaded successfully. Here, as I already told you, like when everything has been loaded successfully, model and scalar will be loaded successfully, will be shown after the home page has been accessed, because this is the home page we have taken, and we have given the input data. First our input data and the scaled data. We can also see the scale data. It's, as I already told you, it's between like 0 and 1. So we have got the comma as this one, and after that we our input, and after that, after everything, like it's the same way, like the given second input and the scaled data and the output, and next third one and scaled data, and everything has been saved. Like after doing everything, we have accessed our home page. So that's the reason it shows like home page has been accessed. So in this way, I have successfully implemented my machine learning model using I have implemented my machine learning model, and make that machine learning model user friendly so that each and every person can use it. Thank you.